this presentation, we demonstrate the design of a cybersecurity system architecture that is built by implementing VLAN segmentation, an OPN-Sense firewall, and a SIEM platform as the central component for security monitoring and threat detection. The topology we designed consists of multiple virtual machines that are deployed across separate network segments. This design aims to improve overall system security, reliability, and access control by clearly separating network functions and limiting unnecessary communication. Within this architecture, we define 3 distinct user roles. First, general users, who access application services from the internet. Second, the system administrator, who has full access privileges through a secure VPN connection. Finally, the security analyst, who is responsible for continuous security monitoring and incident analysis using the SIEM platform. On the server side, the system consists of several key components. A load balancer virtual machine is placed in the DMZ zone, functioning as a reverse proxy and web application firewall. There are 2 web server virtual machines that provide application services, a database server VM that manages application data, a backup database VM that ensures data availability and recovery, and a CM VM responsible for log collection, threat detection, and security alert notifications. All traffic between users and servers, as well as inter-server communication, is centrally controlled by the OPN-Sense firewall. This ensures that every connection is strictly permitted based on user roles, server functions, and operational requirements. First, we start with the firewall rules for the DMZ network. In this configuration, the DMZ is restricted from accessing internal networks such as the LAN, database server, and backup database. The DMZ is only allowed to access the internet, forward traffic to the web servers through the reverse proxy mechanism. With this rule set, if an attack originates from the internet, its impact is contained within the DMZ and cannot directly reach the internal network. Web server firewall rules. Next are the rules applied to the web server LAN. Web servers are not allowed to access the LAN or the backup database, preventing movement into unrelated network segments. Web servers are only permitted to communicate with the DMZ as the entry point for user traffic, access the database server for application data processing, send log data to the SIEM system. These rules ensure that web servers function strictly as the application layer without excessive privileges. Database server firewall rules. For the database server, access is tightly controlled. The database server is blocked from direct access to the LAN and DMZ, ensuring that it cannot be accessed directly by users or from the internet. The database server is only allowed to communicate with the web servers, send data to the backup database, forward logs to the SIEM platform. This configuration significantly improves database security by limiting access only to systems that truly require it. Backup database firewall rules. The backup database is protected with even stricter firewall rules. This server is not allowed to access the LAN, DMZ, or web servers. The backup database is only permitted to receive connections from the database server, send log or status information to the CM system. This isolation ensures that the backup server remains secure, even if another server is compromised. SIEM firewall rules. Next are the firewall rules for the SIEM VLAN. The SIEM system is blocked from accessing internal VLANs such as the DMZ, web servers, database, and backup database. However, SIEM is allowed to access the internet for threat intelligence updates, integration with external services such as VirusTotal, sending security alerts via Telegram. The SIEM functions as a passive monitoring system, not as an application server that directly interacts with production services. OpenVPN access for system administrator. For administrative access, we implement a dedicated OpenVPN connection for the system administrator. Through this VPN, the administrator is allowed to access all VLANs, including DMZ, web servers, database server, backup database, CM. This access is required for maintenance, troubleshooting, and system configuration, and all activities are performed securely through the VPN. OpenVPN access for security analyst. In addition to the administrator, we also provide a dedicated OpenVPN connection for the security analyst. This access is strictly limited to the SIEM VLAN only. With this restriction, the security analyst can perform monitoring, log analysis, and incident investigation without having direct access to production servers. Web server components and services. In this section, we explain the components and services running on the web server layer of our system. The web application is developed using Flask as the backend framework. Flask handles application logic, processes user requests, and manages interactions with the database. For web service handling, the system uses Nginx as the web server. Nginx receives HTTP requests and forwards them to the Flask application running in the backend. At the front layer, we also deploy an Nginx load balancer located in the DMZ zone. This load balancer distributes incoming traffic across 2 web servers, ensuring balanced workloads and maintaining service availability. For data storage, the system uses MySQL as the database server. Access to the database is strictly limited to the web servers, in accordance with the predefined firewall policies. Through the combination of Flask as the backend, Nginx as the web server and load balancer, and MySQL as the database, this web server architecture is designed to support security, scalability, and efficient system monitoring, SIEM implementation, and testing results. Next, we will explain the SIEM implementation in this system, along with the results of our testing. In this architecture, the SIEM platform is used as the central security monitoring system. Its main function is to collect, analyze, and correlate logs from various system components, including the web servers, database server, and the firewall. To evaluate the effectiveness of the system, we conducted a simulated SQL injection attack on the web application. This attack was performed through application input parameters, with the objective of testing whether suspicious activities could be detected by the security system. The test results show that the SQL injection activity was successfully recorded in the web server and application logs. These logs were then forwarded to the SIEM system, where they were analyzed and correlated. The SIEM successfully identified the attack pattern as anomalous and malicious activity. Once the attack was detected, the SIEM system automatically generated a security alert, which was then forwarded to Telegram as a real-time notification. Through this mechanism, both the system administrator and the security analyst can immediately become aware of potential attacks without the need for continuous manual monitoring. The implementation of this SIEM solution demonstrates that the system is capable of early attack detection, centralized log management, and rapid response through automated notifications, thereby significantly improving the overall security posture of the system.